Okay, now on this big ideas page, they've given you some graphs, and of course I could always reach for Desmos and just type in equation A and see which graph it goes, but there's a way we can narrow it down with what we've learned so far. I know that this thing with the +4 on the end, we've talked about how standard form, that +4, means that it has a y-intercept of 4. So that means if the y-intercept has a 4 on it, I'm looking for a graph that crosses the y-axis at 4. So that narrows me down. It looks like C is pretty close to 4, and looks like graph D is close to 4. Now, to narrow it down further, this also has an x squared, meaning it is a degree of 2. So this is a degree 2 graph. And since the degree is going to be 2, I'm going to need it to only have about 2 x-intercepts. The degree tells us the maximum number of solutions. So D basically crosses the x-axis too many times. It cannot be a degree 2 graph. C does cross the x-axis exactly twice. With the degree of 2, it could actually be 2, 0, or 1 x-intercepts. But it's a max of 2, so C has to be the graph that goes with A. Now, once I have the graph matched up, I can use this graph to figure out the answer in factored form. So this has x-intercepts of -1, and it also looks like it has another x-intercept of about -4. So if those x-intercepts are -1 and -4, that means my value there is going to be an x plus 4 and a x plus 1, because once again, you have to switch the sign when you put it in the parenthesis to make a factor. So that -4 becomes a +4, the -1 becomes a +1. And not only I use the standard form to find the correct graph, and then I use the graph to get it in factored form. B, I can do the same thing. This is something harder than what we've learned how to do algebraically so far. We might look at how to do that algebraically later. But the truth is, we have the graphs here, so we don't have to know how to do that algebraically. I'm once again looking for something now with a y-intercept of close to 2. So ones that cross the y-axis near 2 would be F, and that's it. So I know it has to be F. I can check the degree. This has a degree of 3, which means I would be expecting a maximum of 3 x-intercepts. So this graph does have 1, 2, 3 x-intercepts, about what I would expect from a degree of 3. But remember, I could have less in certain circumstances. So graph F, I would have a -1, a +1, and a +2. So those are my x-intercepts. So when I go to factor it, that -1 becomes a +1, x plus 1. The 1 becomes a -1, so x minus 1. And the 2 becomes a -2, so x minus 2. And I'm sorry, my cursor is lagging a little bit, but that is an x plus 1, x minus 1, and an x minus 2. On each of these, you could continue to use the same basic methodology. Let's see, one worth mentioning also is C. We'll go ahead and work it together, and then I'll give you all a chance to try the others on your own. On C, since it has a -2 there, what I would expect, it does not have a plain number. You see that -2 has an x with it. That means the understood y-intercept is it has an understood +0 sitting there. So it has a y-intercept of 0. That means I'm looking for something that crosses the graph through 0, 0. So that gives you the choice. This graph goes through 0, 0. This graph B goes through 0, 0. And then this graph E also goes through 0, 0. So that did not narrow it down nearly as much this time. The second thing I could do is I could look at the degree. Since the degree is 3 on this one, that means that answer A is acceptable because it looks like it has 3 x-intercepts. Answer A looks like it has an x-intercept at -1, 0, and +1. And then B looks like it has 1, 2, 3, 4 x-intercepts for B, so that cannot be what I'm looking for. E also looks like a possibility because it has 3 x-intercepts at -2, and then also 0, and also +1. So E does have 3 x-intercepts as well. So B is not really the answer for this one, but A and E both remain possibilities. Now, finally, if I think about it, if I were to multiply this together, a 1 times a 1 would never give me a 2. but a 2 times a 1 could possibly give me a 2. So I can use that kind of as a last resort to think, if I were to multiply this out, which of these is a possible factor? As we continue on with this problem, we can see that the better answer between A and E, because it does allow me to multiply to get that 2, is E would be the best match to C. And then if you ever get stuck on one like that, it's a lot better to have two equations to graph and figure out which one goes with the graph, since you kind of narrowed it down, than it is to be looking at all of them anyway. So if you're not able to think all the way through that, don't worry about it too much. You can at least narrow down your options. Now the catch is here, I have a x plus 2 for the 2, and then I have an x minus 1 for the 1, but then I have this 0 gives me a factor of just an x in front. And it would have been best probably, if I was trying to factor that, for me to go ahead and factor out an x, because I can see it has a GCF of x. And if I would have taken that out, I would have avoided some of that confusing ambiguity between A and E where the graphs look so similar, and it would have helped you to arrive at the correct answer more quickly if you would have looked for that GCF. I'm going to give you all a chance to go ahead and try the other problems on this page. Hopefully you can finish them up. And if you got any questions, contact me via Zoom or email.